Okay, so now in the next part, now that we are already comfortable knowing what 2D arrays are and what are the functions related to 2D arrays, now is a good time to actually move forward and start solving a bunch of questions. Okay. The first question is printing the 2D array in the wave format. Okay, what you saw earlier was, right, and assume that the questions now that we are going to solve, they are not going to be jagged arrays. Okay, if I say a 2D arrays, it will either be a square matrix or it will be a rectangular matrix. Okay, it's not going to be jagged. The questions that we will solve will focus on square or rectangular arrays only, 2D arrays only. Okay, if you will see earlier, what we did was, here we actually printed the elements, right? Here we printed the elements in horizontal format. For example, if the array was this, right, the output was across horizontal lines, right? The output was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? We went to each and every row, we printed each and every row and then went to the next row. Now what you have to do is, you have to print the elements in the wave format. The output should be wave format. So for the given array over here, the output will be 1, 5, 9, 10, 6, 2, 3, 7, 11, 4, 3, 7, 11, 12, 8 and 4. Okay. Basically, you have to print the elements like this. Okay, I want the output to be like this. If let's say the input is this, right, I want the output to be 1, 4, 7, 8, 5, 2, 3, 6, 9. Okay, I've shown both examples of a rectangular and a square array so that you can find or understand how it works, right? So this is the question that we are now expected to solve. Okay, now that we've given a thought, what we will do is we'll try to see what could be the solution for this problem. Okay, so far previously how we have been printing the elements is, we have been moving in this order to print the elements, right? And we have been moving from one row to another row. What you can clearly see over here is that the pattern has changed. We are moving like this, or maybe like this. Okay, these are the two directions which we are moving in. That means we are going to all the columns one by one, and for that column we are printing all the elements of that column. Okay, that is what we have been doing, right? We have been going to each and every column, and for that column we have been printing the elements. That is one thing. Another thing, what you will realize is, if you make careful observations, this was what? Column 0. This was what? Column 1. This was what? Column 2. Right? And this was what? Column 4. Can I say that if the column value is actually even, I am always moving down, like in this case and like in this case? And always when the column value is odd in zero based indexing, I am always moving like this. Does that make sense? And like kind of help you to make a very careful observation about this question, because we are moving in a wave like a format, right? So we need to make a careful intuition on when are we moving up and when are we moving down, right? And the idea being that whenever the column value is even, we are always moving down, and whenever the column value is odd, we are always moving up. The moment you figure this part out, the question is a simple cakewalk for you. Okay, now I think the question is pretty much solved. Okay, now it is more or less about how efficient you are in implementation, because that was the only intuition that was required. Wave display. let's pick a matrix from here. Okay, and always we will do the good implementation and use functions. Wave display, and I will do this. Okay, here we are passing an array. Now, like I said, you are moving in a vertical format. That means you now go to each and every column, and for every column you now print the values. That means you do for int c is equal to 0. You will go, this is, like I said, it could only be a square or a rectangle matrix in the question. So you can use this format. This is how you are going to each and every column. Okay. Now you check two scenarios. If the column value is even, you move down. Okay. Else the column value is odd, so you move up. Okay. Now for every column, you go to each and every row. R is less than total number of rows is this, and you do R. Okay. And over here, you print the row, you print the column, and you do this. Okay. For a more, for a one line output, all of it is in one line, you can do this. Otherwise, you are moving down. That means you are going from row 0 to the last row. Okay. But if you are moving up, then you are starting from the very last row. Okay. And you are making your way to the row 0. That is the only difference. Okay. I think we are done. Let's verify. So we have 1, 3, 5. Then we have in the output 6, 4, 2. So we are moving up. Then we have 7, 8, 9. We are moving down. And then we have 12, 11 and 10. Okay. And this is how basically you can do a wave display of the elements. Right. You're moving up, you're moving down in a certain format over here. Right. This was ideally like this only. Like if you want to kind of see internally, there were 3 rows. For every row, there were columns. So initially you were at column 0. So when you move down, that means you go from row 0 to row 1 to row 2. You were going like this. But when it was time to go up from col 1, you were moving like this. So you were starting at row 2 and you were going to row 0. Okay. And this is the question, wave display.